Okay, welcome everyone to MIPIN's May webinar utilizing spray drones for managing invasive Phragmites. Our presenter today is Dr. Reed Smita with the University of Missouri, and we'll give him a full introduction in just a moment. But I always like to just make sure everyone is familiar with the Midwest Invasive Plant Network. We've been around for about 20 years. We have a mission to reduce the impacts of invasive plants in the Midwest. We cover a 10 state and province region. And we are very fortunate this year to have several sponsors who are supporting our work. So I want to share, express our appreciation to the Invasive Species Center in Ontario, Ecologic in Indiana, Wild Type Native Plant Nursery in Michigan, and Mark M. Holman Inc., landscape architects and contractors out of Indiana. So thank you all for supporting the Midwest Invasive Plant Network. And I want to give a special credit today to the Invasive Species Center. They are sponsoring this specific webinar. They are a not-for-profit organization. They mobilize action against invasive species that harm the environment, the economy, and society. They are a hub for collaboration and knowledge sharing, and they're a respected partner and leader in invasive species science, education, and action. They have a great website, invasivespeciescenter.ca. You can find a lot of information about a variety of invasive species and projects that they are involved in. Highly recommend that. And if you want to learn more about MIPIN's work, you can go to mipin.org. We have an up-to-date Midwest invasive plant list, so you can see how plants are listed and regulated across our region. We have annual conferences. Our next one's coming up in October of this year. That's the Upper Midwest Invasive Species Conference. It's going to be in La Crosse, Wisconsin. We maintain the Woody Invasives of the Great Lakes Collaborative, and that website is a treasure trove of information on all things woody invasives. We maintain a directory of CISMA coordinators, so that's Cooperative Invasive Species Management Area. So if you're looking for local support or have questions about what's happening with invasives locally, they are great. You can find your local contact person. And we also have information on everything from, early detection priority species, how to identify them, how to manage them, how to restore sites post-invasion. Lots of different information, again, mipin.org. And you can stay connected to us. We have a quarterly newsletter you can sign up for on our homepage. You can also sign up for our email listserv there. We have an events page and calendar, which might be how you found out about today's event. And we're active on several social media platforms. You can also just drop us an email anytime, mipin@mortonarb.org. And while we are very grateful to have sponsors, we also rely on individuals for support. So if you are in a position to help us out today with any amount, it's very appreciated. There's a QR code here, but I'll also drop a link in the chat once we get underway. Okay, so I'm going to stop sharing and invite our presenter to share his screen. And yes, so I want to welcome today Dr. Reed Smita. He's a professor in the Division of Plant Sciences at the University of Missouri. His areas of research include agricultural weed management, weed herbicide resistance, and control of invasive species outside of an agricultural context. He's particularly interested in industrial vegetation management, the management of problem vegetation along transportation corridors, utility lines, and in other developed settings. And as the education coordinator for the National Railroad Contractors Association, he arranges annual training for pesticide certification exams. Very excited to be here about his work today with drones and managing of invasive Phragmites. So are you able to share your screen?
Let's see, I thought I did. Let me go back.
And I will let you know once I see that start to load.
Mhm.
Oh, I think there we go.
Okay,
Looks great.
we're good.
All right, take it away, Dr. Smita.
All right. Thank you, Michelle, for that introduction, and welcome everyone. I'm sure a number of you are here hoping to learn more about Phragmites, maybe in a good way rather than in a negative way. I remember growing up in Southwest Michigan, grew up on a strawberry farm. Whenever we would travel down to visit any relatives in Iowa, we always passed through south of Chicago, and I was just amazed at this tall grass with this large pluming seed head everywhere on the roadside around Chicago. And I thought, wow, what is that stuff? Once I had gone to college and learned a bit more about weeds, became familiar with Phragmites, eventually became a assistant professor here, now professor at the University of Missouri back in 1996, and started working with invasives around 2005. And this work that I'm presenting today is part of the PhD dissertation work for Emma Gaither. So I'm giving her a shout out and some credit for this. And let's talk a little bit about Phragmites today and talk about using spray drones. Some of this information is probably not uh, something that is unfamiliar to you. And Michelle, I can't seem to advance the slides. Yes.
There we go. Okay, looks good on my end as well.
Okay. All right. Thanks everyone again. Let's get right into the presentation and talk about, first, let's talk a little bit about UAVs, unmanned aerial vehicles. You can see on the right here is a picture of a spray drone that's hovering above some Phragmites. So why would we want to use a spray drone? I think all of us probably know some of the basic reasons, just a couple that I'll highlight. First, you'll hear a lot about applications over the top of agronomic uses in field corn, because at that point, you're wanting to look at potentially putting on fungicides, which potentially could control diseases to enhance crop yields. Spray drones can also be used near aerial areas, near water or aquatic areas where it's difficult to actually get over those with land-based equipment. So we're looking at using it in both applications, where we're looking at control with fungicide use in tall corn, tasseling corn, but also in controlling Phragmites. Another thing that is to be considered when we talk a bit about these types of uses with drones is looking at rotor wash. And I'll define that here in a moment. But this could be another potential benefit for using spray drones to actually increase penetration of the spray droplets into the canopy. So if we look at, let's hope it stays. All right.
Okay.
Sorry, everyone, for the disjointed technology. Everything was working good well before. So we
Yeah.
talked about a couple of different things then that could be advantages for using drones. One is the height of the vegetation or near aquatic areas. Another is the potential use of rotor wash for greater penetration in the canopy. Rotor wash is downwash, or that high-speed downward airflow, as you can see pictured here from a helicopter, which the spinning propellers then generate the lift necessary for the flight of the helicopter, but also result in pushing things below the helicopter downward. Of course, that can lead to something that we call outwash, which is, as we'll see, could be a concern when it comes talking about spray drift or off-target movement. So what are some challenges with using a drone to actually apply herbicide? And there's several things I want to highlight. One is, first, there's a number of pesticide labels that currently lack drone information, even though there are some that do. In this scenario, the drone then, if it doesn't have drone information specifically, must follow all the guidelines for traditional fixed wing aircrafts or helicopters, and sometimes those can be quite restrictive. In addition, some herbicide labels state that if all guidelines cannot be followed, then the applications with the drone cannot occur. So there could be some things on the label that you think, okay, I can follow those, but I can't follow this, so therefore I can't use the drone application. In addition, there are some pesticide manufacturers who may add drone applications to new pesticide labels, but typically for modifications to existing labels, that actually can be quite expensive. Just a brief view for the EPA, there's a PREA 5 fee, which can be about $19,000. Some states also have application fees for modifying pesticide labels, and that could add up to somewhere around $21,000 per herbicide label. So those can be somewhat expensive as well. In addition, there are a number of different designs of spray drones, and that creates challenges in forming general application language guidelines on labels to make sure that there's minimum adverse effects, which labels, of course, are supposed to cover. So why does somebody want to have a DJI drone versus a TTA drone that we used for this? If there's many other drone designs, you've got to have the language which makes sure that all those things are addressed on a label. where again, you've got to follow label guidelines for fixed wing aircraft. Fourthly, when we look at guidelines on using spray drones, they can vary between states. Of course, states have opportunities to modify or put additional restrictions on as well. Some states will permit drones to apply pesticides via aerial application guidelines. Other states may require specific language that addresses drones. So we're in this transition period where we're not in a mature science area using drones. There's still work to be done in that area. Also, certification requirements can be different. So the FAA, Federal Aviation Administration guidelines, are national, but some states can have additional aerial certification, while other states may require additional certification. Besides drone certification, you may need an aquatic or a right-of-way certification on your license to be able to use the drone in that application. Fifthly, when you're making applications, the FAA requires that two people are present when you're making a drone application, unless you have a waiver. You need the applicator themselves and you need a visual observer. And the visual observer's role is to look for obstacles or other hazards to maintain that it stays safe to fly that drone. This visual observer must maintain a line of sight where they can keep line of sight with the drone at all times. That can sometimes be challenging in tall canopies, in a rolling topography, or sometimes even behind tree lines that you can't currently see unless you start the spraying process. Finally, drones were designed to capture imaging and other data. We still have a lot of information to learn yet about using drones for making pesticide applications. The last thing that I'd like to highlight as a potential concern is off-target movement. There are several different factors that can influence off-target movement when we're using a drone. And a drone has specific types of needs when we're making applications. So here are some of the things we have to be concerned about. Anytime our flight speed or the height above the target area increases, especially if we're 10 feet above the target area, and typically you have a LiDAR detector on the bottom of the drone that keeps that target distance from the target vegetation. But as you increase speeds or flight height, you're going to see a longer time period for that spray droplet to fall, potentially interacting with the environment. If you have a crosswind, it can move some of those droplets off target, perhaps to areas that you don't want them. In addition, at lower spray volumes, and drones typically can put on from 0.5 to 5 gallons per acre, typically, could be a little bit more, up to 8. But the result of that is using finer spray droplets that have concentrated pesticide in them in order to improve spray coverage. But those finer spray droplets, again, have an opportunity to move off target. Next, we have to mention nozzle type. There are some rotary atomizer type nozzles. These are small spinning discs that can result in very uniform droplets, so you can control droplet size. The problem is that the drift risk with those nozzles is higher than conventional hydraulic nozzles, because those nozzles actually force the particular droplets downward, while the rotary atomizers can actually result in droplets that are moving outward. Finally, vortices and aerodynamics. When we consider that the boom, which is where the pesticide moves through before it comes out the nozzles, if you have a wider boom configuration beyond the rotors themselves, that can sometimes trap the droplets in a wingtip vortice situation, resulting in droplets that are forced away from the spray pattern, as you can see in this example here in this picture. So all of these things have to be considered when we want to use a spray drone for making application. A couple of things about the spray drone that we used. This is a TTA M6EX. You can see that it has the global positioning system there on the top of the drone. We have all the other typical type applications. We've got batteries that held about 18 minutes. We have a LiDAR detector for height detection. There's a pump on the bottom, a hydraulic pump to be able to push the spray out. Then we've got a tank and nozzles. And some of the details about the potential of this drone are listed below. The maximum speed, the range of the controller, that's for line of sight, wind resistance with winds which you can spray in, the type of nozzles, and we used a Leckler ID. It was a 120-degree nozzle with an output of 0.2 gallons per minute. And then we had a wingspan of 51 inches, and the weight of that was 54.9 pounds. As an aside, we had to be below 55 pounds when we used this drone. Otherwise, the University of Missouri said we needed liability insurance equivalent to the jet that the president of the university uses to fly around. Somehow, that magical, if you're below 55 pounds, was where we had to be. So, these are some of the details then about that drone. Now, a little bit about what about rotor wash? Can we estimate that? So, in an application using field corn, when we sprayed during tasseling, we used a compound called calcium chlorate, which can be used actually as a desiccant. We applied that in a liquid application using the drone and also a backpack, and we sprayed over the top of corn, and we wanted to see what the distribution of droplets could be among the canopy within the corn. So we sprayed various plots. We applied, and we did this a couple of different times. And some of the results of that are shown here in this particular figure. So some methods. We sprayed corn at tasseling. We made back-to-back applications at 150 liters per spray volume, liters per hectare. That's about 16 gallons an acre. And we looked at the potential for deposition 3 days after application. So the calcium chlorate works pretty fast. The results of this, and you can see the light tan area, that shows you with the backpack applications that were made at 150. The 75, 37, and 19 liter per hectare application were only done with the drone. So you can see when using the drone, when you look at the lower canopy position, this is close to the ground versus the middle of the canopy. That would be about 2.5, 3 feet above the ground, up to about 6.5, 7 feet. And then the top upper 15 to 25% of the corn leaves, you can see that there's a fairly uniform, not significantly different deposition of spray in all parts of the canopy using a drone, irregardless of the spray volume that we used. However, when we used the backpack and sprayed over the top of corn, simulating a ground-based applicator, you can see we had significantly greater deposition in the upper part of the canopy. Again, giving some evidence that using the spray drone could push more deposition lower into the canopy to improve coverage, depending on the material. Now, if we're applying a systemic herbicide, we're expecting this to translocate throughout the plant, but getting it further into the canopy can actually improve potentially phloem transport throughout that targeted plant. Well, that was enough about drones. Let's talk a little bit about Phragmites australis. And I'm probably preaching to the choir here at some point, so not going to cover a lot of information, but to give a little bit of perspective. So this is primarily a wetland grass, originated from Eurasia. It does compete, and there is a invasive species, competes with a native variety. It forms extensive stands that we call reed beds in wetlands, and it can tolerate brackish water, standing water all year, or even riparian type areas. It's been documented to grow up to 6 meters tall. Most of the material that we were dealing with was generally in the 8 to 12.5 foot tall range. So we weren't looking at the tallest of that, but nevertheless, some good invasive stands. How many species of Phragmites australis are there in the US? Well, information that I'm able to find is that there is a native species, often confused with the invasive type. There is an introduced subspecies australis, which is the invasive one. And then there is a third species that's found throughout the southern US and Mexico. It's a subspecies Berlanderi, and its origin is somewhat debated. Some consider it invasive, some consider it native, some consider it a hybrid. So the primary one that we're working with is the invasive subspecies australis Phragmites. Now, what makes this species difficult to control? About 60% of the plant volume is actually at or below ground. So that's the first thing we have to remember is it has an extensive root system. So extensive that whenever we worked in specific areas, I tried to take a shovel to dig into the area to dig out some Phragmites, and the rhizomes were so extensive, it was difficult to actually dig into the ground. You had to break off the rhizomes in order to get underneath them to dig anything out. They form a tall, dense growth. They like aquatic and riparian areas that are not necessarily easily accessible with ground-based equipment, hence the experiment with UAV equipment. The stolons and rhizomes allow Phragmites to spread quickly. Now, why would that be a problem? Well, we're going to take a very one slide break from talking about Phragmites to give you another species with an example, and this is Canada thistle. This was some work, and Purdue has done some years ago. They took a 4-foot area. This is the width of a 4x8 sheet of plywood. They built actually above ground this area that they kept covered with plywood. They put chicken wire to keep the soil there. They planted Canada thistle. And then they looked a year and a half after they planted the Canada thistle. And lo and behold, when they took the plywood away from that, what you see is the above ground vegetation that's there, but more significantly, this extensive creeping root system for Canada thistle. Now, that is in itself an advantage for the perennial because in the area of pollution, we say dilution is the solution for perennials or for pollution, but dilution is the solution for the survival of perennial weeds. And as we look at trying to control these weeds, we have to remember there has to be enough delivery of pesticide in one single dose if we're making one application to be able to control this particular extensive root system in addition to the shoots. And that's often very difficult to do. So imagine that type of layout now for Phragmites. Now, one thing I mentioned a couple slides ago was this aspect of stolons. Most of us tend to think that Phragmites produces rhizomes, but where we worked up in an area east of Macon, Missouri, was along a railroad right-of-way. We got permission to be able to work there, and we went across the railroad there at that point, and I saw that there was this long stolon up to 17 feet long, and it went from the left side of your screen where there was actually a stand of Phragmites, and it went to the right side. It actually went underneath the rail over the top of the ballast area, and you can see that there, went underneath the rail again and came out the other side and had started Phragmites growing on the other side of the railroad track. So it was able, not below ground, but above ground with a stolon, and you can actually see the shoots of that green tissue going underneath the rail line and showing that this species can produce a stolon. So something perhaps we've not thought about or maybe known or observed before. Most of us are, of course, familiar with this typical type of stand with the tall canopy, the extensive root system, allowing exclusion of most other species. I will say that about 15 years ago, I had a couple of duck hunters contact me, and there was a small lake up in north central Missouri, and they were tired of always using duck decoys, and they wanted to be able to go out and hide among some vegetation close to this lake and be able to go ahead then and during duck hunting, shoot ducks legally. So they wanted to know if they could plant this Phragmites. And I said, don't do it. It's going to ring your lake in 5 to 10 years, and it'll form extensive stands, and you're not going to be able to get through. I never heard from them again. Wish I had known the lake, but that's a bad idea, is to recommend Phragmites to plant around a lake. So what are the objectives of some of the research work that we wanted to do then with the UAV and looking at Phragmites control? First, we wanted to compare the treatment efficacy using a drone versus a ground-based herbicide application system for controlling Phragmites. We wanted to determine the optimum timing of the foliar herbicide applications. Would it be summer? Could it be fall? We didn't show spring here, so we wanted to look at summer and fall and show most of that data. We also wanted to work with a newer active ingredient from Corteva called fluoroperoxyfen benzoyl. Rinscore is the trade name. We wanted to determine if it could exhibit some efficacy on Phragmites as it does on some other perennial type species. We also wanted to evaluate rhizome regrowth in treated areas and determine non-structural carbohydrates in rhizomes following treatment. So let's look at the treatments that we used. I've got the rates here listed in metric terms, but one of them besides the untreated control was glyphosate, and this would be the typical type glyphosate at about a quart per acre, about 32 ounces per acre. We then looked at glyphosate and using that Rinskor compound, which is a very low use rate per hectare. We also compared imazapyr. That's another active ingredient which shows efficacy on Phragmites. We used that at about 24 ounces per acre. Then we looked at a couple of combinations, imazapyr plus Rinskor and glyphosate plus imazapyr. So those are our 6 treatments, and I'll include a small table in some of the data slides so you can follow along with some of the types of results that we experienced. I should also mention that we use Control Duo. That was our material, which was a drift reduction agent. We've added that to our drone to try to reduce the amount of off-target movement, in addition to following height above application and making sure that we didn't spray too quickly and not on windy days. All the treatments were applied with the UAV. We also used a backpack sprayer, and both of those applications were done at 16 GPA. Now, you might ask, why didn't we use 5 or 8 GPA for UAVs? We wanted to compare at the same spray volume, so that spray volume was not a factor that could determine differences, but rather the delivery method that we could use. So application methods. We did use our TTA M6E spray drone. We operated at a speed of 6.8 miles per hour, and this could be easily controlled using the controller as Emma did. Target height above the canopy was about 5 feet. So that's where we were above the canopy. For the backpack application, and this is an example of that, even though it's from corn, we used a rear, we call a behind backpack sprayer. So we had a raised 10-foot boom that was mounted onto a frame that we could walk through either the Phragmites, we mowed a path through it, or we went through rows of corn to be able to make these applications. Walking speed was 3 miles per hour. Looking at application timing, we wanted to look at an early August timing, and we put it on intact Phragmites that was 6 to 8.5 feet tall. We also looked at a late September application, and this was done in Phragmites that was actually mowed off. We mowed that 3 months prior to treatment and then allowed regrowth. Sometimes there's an extensive amount of dead vegetation from the previous year, so we wanted to see if it would make any difference what type of Phragmites we were trying to target. Now, you might ask yourself, why late summer to fall applications? For most of us familiar with weed biology, we know the answer to that question. This is a picture of Johnson grass, again, not Phragmites, and it's to highlight the fact that when we look at what plants are doing, we know that Phragmites will die, the shoot tissue dies down to ground level, as does Johnson grass. So what happens during the year to some of the photosynthate or the energy that plants use? And we know that the direction of the photosynthate, primarily flowing to the phloem, can move up and down in the plant, but as we approach later summer and fall, the direction of that photosynthate is primarily downward into the root system, or the rhizome, as you can see in that right-hand picture, and it begins to build that root system, storing carbohydrate for the next growing season. That is an ideal time to deliver a systemic or translocated herbicide because it will follow through those carbohydrates down through the phloem and store those in the roots. And we found that you can get excellent activity using glyphosate, a systemic herbicide, as well as imazapyr for getting that type of activity. Of course, sulfosulfuron or outrider is used a lot for Johnson grass with applications in the fall, and you can see good to excellent activity making an application at that time. So we were using that knowledge of weed biology to make then those later summer and fall applications. Where did we do the work? We did it in 2 different years. We looked in 2021 at using this material down in Pyramid State Park within Illinois. We collaborated with folks there. We also did an application just east of Macon, Missouri, and northeastern Missouri. And then in 2022, we went again to Pyramid State Park. We also went along Interstate 72, working with Illinois Department of Transportation and putting it out there on some right-of-ways. So these are the areas that we worked, all had well-infested and well-established Phragmite populations. What data did we collect? In the weed science community, we typically use visual injury ratings. The eye sees an awful lot in terms of assessing what the type of control could be on a shorter or longer term basis. So we looked at a 0 to 100 system, 0 being no control and 100 being complete plant death. We also rated these plots that we had sprayed, and they were anywhere from 10 to 45 to 10 to 50 feet in size, 10 feet wide, 50 feet long. We looked at 1 month, 1 month after treatment, the end of the growing season, those were in November, and then we did 1 year after treatment evaluations. We also counted living and dead stem counts done at the end of the season, both in November of 20 and 21. I'm not going to be presenting that information today. And then I will be presenting some information on rhizomes that we collected at the end of the season both years, looking at potentially what would happen with rhizome regrowth. So we wanted to know what the potential was for new shoot formation, putting them in a greenhouse situation where they would germinate very readily, and we wanted to see what the longer term effect of the herbicide could be. We also looked at total non-structural carbohydrate analysis, and these are some of the data pieces that I'll be sharing today. So let's talk about visual injury. First, we'll look at end of season. So this is approximately 60 to 75 days after application. Again, the treatments are listed there, and you can see the treatment on the bottom of your figure. Treatment 1 obviously had no control, so there was no need to show the visual rating for it. And as you can see, when we made an aerial versus ground-based application, we had a little bit higher control with the ground-based application, but in many situations, this was not statistically different. We saw that for glyphosate applications, glyphosate alone or with Rinskor, you saw slightly lower levels of visual control than you did where we added imazapyr. And it should be pointed out that in treatment 6, where we used imazapyr, this was at a lower rate, about 12 ounces per acre, versus treatments 4 and 5 that had the 24-ounce rate. You can also see that the addition of the Rinskor, either to treatment 3 or to treatment 5, did not necessarily consistently boost control to a point where we felt that the Rinskor was an active herbicide on that. And we saw activity in all the plots that we looked at. This would be a representative photo. You can see end of season. Here's your untreated control on the left slide. And here is a plot showing you glyphosate plus imazapyr. Again, you see the chlorosis that's present. Imazapyr does do this on plants, especially in some of the new growth that's there. But nevertheless, you see shoots trying to form and force new growth. But you can see extensive thinning of that particular stand. If we look at the data from 1 year after treatment, what you'll notice, and this is combined for both UAV and backpack data, and we combined it over locations, what we saw was that the glyphosate application, either alone or with Rinskor, definitely exhibited less control than where we saw combinations with imazapyr. So imazapyr, at least in our research, was a more active ingredient on the Phragmites. And again, the Rinskor product did not boost control over the individual herbicide itself. This is a 1 year after treatment showing you the imazapyr activity. So you can see again from end of season through the following year in some of the plots, very good to excellent activity. Some small areas with some growth trying to come back from shoots, but overall very good control with the untreated control in the background. I would like to note, and it's not present in this picture, throughout the trial, especially in the area close to Macon, Missouri, we had a lot of Bermuda grass that was present. And in those plots that exhibited excellent control of Phragmites, we saw an awful lot of Bermuda grass trying to come back, obviously from dormant, either stolons or rhizomes, now starting to reestablish. We didn't see a lot of broadleaf. There were some broadleaf weeds coming back, but you could definitely see annual grasses and annual broadleaves now emerging in the plots where the Phragmites had been removed. again showing you the extensive ability of Phragmites to exclude other species. Now let's consider some aspects of rhizome health analysis. So again, when we took end of season data in 20 and 21, we wanted to look at what kind of effect on rhizomes we saw. So we took a volume of rhizomes from representative plots for all 4 replications. We placed them in greenhouse 10-inch by 20-inch black flats that we filled with a 70% pro mix. This is a mix containing sphagnum peat moss and other types of high organic matter materials, very good growth media. We mixed that with 30% of a silt loam. We put that into the flats. We fertilized the plots weekly with a light grade of fertilizer. We watered them as needed, and we took emergence counts weekly. And 8 weeks after, we looked at above ground biomass and collected that data in order to evaluate what did the rhizomes from the plots treated, either with the drone or the backpack, look like. In addition to that, we also took some of the remaining rhizomes that we didn't use for our growth analysis. We dried those, we ground them, and we analyzed them for total non-structural carbohydrates, where the sugar was quantified by sulfuric acid hydrolysation, and the starch then was measured as a glucose hydrolysate after starch digestion. We followed a published procedure on that because we wanted to know, could we determine more from the rhizomes as far as the efficacy of the herbicide that was applied? Did it weaken the rhizomes within those treated plants? This is a picture of what things look like at approximately 1 month after we had established our rhizomes. You see the untreated control on the left, and on the right-hand side for the left picture, you'll see the imazapyr application with a backpack. On the right-hand side, you'll see that same imazapyr treatment that was put on with our spray drone. So you can notice the dramatic decrease in the actual amount of new shoot growth for those rhizomes following our applications. And again, end of season collecting those rhizomes. Looking at that particular greenhouse growth data and considering the dry weight of the rhizomes as a percent of the control. So now what we're looking at is what's going on with our shoot growth. And you can see, again, when we look at the untreated control, not included here, it's a percent of that control. You can see that the glyphosate, either with Rinskor or without, you can see that we had some suppression, but where we had treatments 4, 5, and 6 that contained imazapyr, you see equivalent or better reduction in the amount of dry weight biomass looking at those particular treatments. And again, we're combining UAV and backpack data. We didn't see any difference between those, nor over location. Now let's consider total non-structural carbohydrate analysis. We've done this before for Johnson grass, and we've seen some nice differences depending on the herbicide. But as you can see here, when we looked at all treatments, including the untreated control, we did not see actually any real difference between them, except where we had Rinskor combined with imazapyr. For some reason, we actually had more non-structural carbohydrates, indicating greater potential for new shoot formation. But basically, for the other treatments, we did not see any differences. So there didn't appear to be a consistent relationship with a total non-structural carbohydrate content, and this is now in our Phragmites. Work that we've done in Johnson grass did show that the use of ALS inhibitors, such as imazapyr and sulfosulfuron, which is outrider, you could definitely see some type of changes in those particular species. You actually saw an increase in the amount of carbohydrate buildup in the roots, not necessarily a decrease. So again, this type of analysis did not appear to track with visual control or regrowth from rhizomes. So what are some of the results that we can say? First, for 1 year after treatment data, our August and September applications resulted in approximately 60% control. When we looked at the addition of Rinskor, it did not improve control. The control decreased actually when combined with glyphosate, while it went up slightly when we put it with imazapyr. The lower 1 year after treatment visual ratings and the higher regrowth biomass from the treated rhizomes would suggest that we've got regrowth going on and recovery and likely need a follow-up application. The treatments that were containing imazapyr did result in about 10 to 15% greater visual control of Phragmites than treatments lacking imazapyr. We think it's likely unclear if there's any interaction between herbicide treatment and total non-structural carbohydrate analysis. What are some things that we can say in conclusion about what we tried to learn? First of all, the controlled differences between backpack and UAV applications were minor. There were some significant differences, but overall, not large differences. This would suggest that the benefits of using unmanned aerial vehicles in the ease of application outweigh the controlled differences. For some of you that are trying to control Phragmites and using ground-based applications, it's difficult to know where the water is, how deep the water is. Using a drone really simplifies application and allows you to go back over areas. There's some things you have to work out, obviously, with drones. We would typically map all of our plots prior to that so that even though Emma would make applications in a manual mode, we knew exactly where we were spraying so we could actually apply over the plot areas themselves. And sometimes that mapping aspect can be a little bit challenging depending on the shape of the areas that you're trying to treat. We did feel that the accuracy of the UAV applications continues to improve as the technology improves, and it's likely getting easier now than when we conducted this research about 4 years ago. We didn't see that any single treatment resulted in complete death. We had some better than 80 or 85% control, yet we still had some regrowth. And one thing that we know from weed biology is that when you actually decapitate the top of a plant, whether it's cutting or whether it's using a pesticide, you'll release the apical dominance, and shoots further along that rhizome can actually reinitiate growth if there's not enough delivery of herbicide. They have extensive carbohydrate storage in the rhizomes, so they'll likely make some attempt for new shoots, which means sequential applications will be necessary. If you don't, you'll likely just in a few years be back to a stand similar to what you had in the very beginning. We also determined that this Rinskor product for peroxyfenbenzyl did not appear to be a useful tool for Phragmites. We can see activity with this compound in some other types of perennial grasses and perennial weeds, but apparently not for Phragmites. There may be some possible antagonism with the glyphosate for that particular treatment, especially when you looked at TNC content. Finally, the TNC content in the rhizomes did not appear to be a reliable predictor of herbicide efficacy, so looking at rhizome regrowth was, but not TNC analysis. I want to make sure that I thank some of the individuals that were responsible for helping with this research. For the Illinois Department of Natural Resources, who provided areas that we could use at Pyramid State Park, for the Missouri Department of Transportation and Illinois Department of Transportation for allowing us to use those particular areas, for Corteva for donating product, Graco for also providing the surfactant that we used, Greenleaf who provided the nozzles, and our lab who did an awful lot of work, as you probably imagine, going out there, trudging along. I can remember the first year that we did some of this data, when one student found a snake, everybody wanted to get out of the plots. So that's when I had to stand a little bit more in some of the plot area, putting in flags. So these are rather interesting areas to work. And with that, I'd be happy to address any questions that you might have, or possibly if there's any questions in the chat.
Yeah, thank you so much. It was really interesting. Um, we have one question already, but I'll encourage anybody. We have like 8 to 10 minutes where we can field questions. So if you just haven't gotten a chance yet, feel free to go in there and get your question in. So the first one we have is there a reason you didn't include a Rinskor only treatment?
Yes, when we looked at Rinskor, we made a pre-application on a small area with Rinskor by itself. And after 30 days, we didn't see any type of activity with Rinskor. So our thought process was that perhaps it was not going to be a compound that by itself but could it provide some additive or synergistic activity? So we thought that's why we would combine it with glyphosate and imazapyr, two AIs that we know had activity on Phragmites. Good question.
Okay. Have you noticed any difference in public perception between like backpack spraying versus drone applications?
We have used drone applications in other situations, and I will say that drones do make that humming sound. And if you're near areas with residences, you tend to get a little bit more of a crowd in the backyard. They might be looking what's going on over there, hence the um, making sure that we were not trying to get product move off target. I will say that in some additional studies where we looked at the use of the drone, this is again in corn and in some bare ground areas, we use spray cards, which turn purple with droplets that hit those spray cards and looked at some of the analysis. That's how we determined the right pressure to use for our hydraulic pump, as well as the right height above the vegetation so we could stay within what we wanted, which was the width for our spray plots. So we tried very hard, but yes, spray drones a couple of times near the road when we were making spray applications. We actually had people that stopped, took out their phones, and started filming us while we were making some of the applications. So Emma was probably a bit of a celebrity. We never found them posted online. We never got complaints from the departments of transportation, but they can be a distraction.
All right, we have another question here. Was there any difference in treatment effects if the Phragmites was in standing water versus drier circumstances?
Actually, we did not see a difference with that. One of the sites at the Pyramid State Park was water pretty much all the time. It was probably 6 to 12 inches deep, trodging around out there. The site at Macon was pretty much a riparian area. It was wet in the spring, dry through the summer. But when we looked at combining the data and also along I-72, that right away was another riparian, dry during the part of the summer versus Pyramid State Park, which stayed wet most of the time. We didn't really see a difference between that.
All right. If someone chose to use imazapyr as a highly effective option, do you think continued follow-up treatments in subsequent years would negatively impact native vegetation?
So imazapyr is one of those active ingredients that does retain soil activity. It's an acetolactate synthesis inhibitor, and it does have systemic activity, but it will exhibit some soil activity. So there would be some situations depending on what your follow-up intent with that treated area is. Obviously, getting some competing vegetation to take over those areas that we free up from Phragmites is important to not just use control alone, but also come up with a type of follow up vegetation that could keep the Phragmites out. But in my mind, if I was looking at trying to get some type of control, I would probably go in with a combination of a glyphosate plus an imazapyr, and then I would likely use a follow-up application of just glyphosate so that the soil activity would be eventually released that you could potentially overseed with other species that you want to take over.
Okay. Yeah, that sounds smart. Okay. We'll give everyone just another minute or two, see if any other questions come through. But in the meantime, I will say thank you again. Really appreciate your time, Dr. Smita, and sharing your work with us. I want to kind of direct everyone to the chat if you haven't been in there yet. If there's a I mentioned a place to donate if you'd like to support future webinars. Is there also, we have a webinar, post-webinar survey that we're trying to get more feedback on these and continue to improve them. So it's real short, but really appreciate if people take the time to do that. Is there anything you want to say about like kind of next steps in your research? Anything new that you're working on?
Yeah, great question. So we've actually used the drone for making applications over the top of calorie pair. Calorie pair is another one of those that we've done some work on. It's one of those types of more terrestrial species. It doesn't like aquatic areas. and it can grow so thick that you can't literally walk through stands of that. And we've made some applications over the top with some of the systemic auxin type mimic herbicides, and we've seen some very good activity using the spray drone applying over the top. So there are some applications for drones. It does come there with some potential problems because you're spraying unequal heights, so LiDAR detection is very important. But I think there could be some other applications for this. We're not continuing any additional research on the Phragmites. I will say that we did follow up to the area in Macon several years later after this research was accomplished, stopped to look at that area, and I could still actually find treatment differences where you could make out some of the plot areas that we had treated years before. So these effects can last for a while, but again, follow-up applications are likely. Last thing I'll say is, again, thank you for your patience during the technology hiccup. Not sure what happened there. I've done enough of these where it seemed to work, so I'm glad you stayed with us.
Yeah, I'll second that. I appreciate everyone being patient and staying with us. I think I see in the comments, and I'll agree that when you have some data to share about that calorie repair work, I think we'd love to have you present on that at some point in the future. So just to remind everyone, we did record this, so if you want to go back and view it later, it'll be up on MIPIN's YouTube channel. We also, if Phragmites is an area of interest, we had a webinar last month on biocontrol options for Phragmites out of work happening in Ontario. So something that is currently posted. So if you want to check that out. Otherwise, if do you have any final comments before we wind up today?
The only other thing that I would say, I'm always a promotion a person for biological control options, and looking at working in the past with a couple of people from biocontrol have found that in fact herbicides with biocontrol agents can actually be quite synergistic in some situations because you can really weaken that particular type of species you're targeting with an herbicide to make it more susceptible potentially to biocontrol.
Okay, perfect. All right. Well, thanks everyone for joining us today, and we hope to see you at another webinar very soon. All right. And thank you again, Dr. Smita.
You're very welcome. Thank you.
All right. Goodbye.